Picture this: plaster, paint, and grout oozing onto our streets and down embankments, forming toxic sludge that drips into our waterways, contaminating the water that we drink and seeping into the bodies of fish and other wildlife. Kind of sounds like a horror scene from a movie like the Blob, but believe it or not, this is a daily reality at countless construction sites around the world. Did you know that every year an estimated 60 billion liters of polluted water filled with chemicals and microplastics are discharged from construction sites, affecting not just the environment, but the food chain itself? Hello, I'm Mike Lake, and in today's episode of Preview of Tomorrow, I'll be speaking with Andrew Crimston, founder and CEO of Washbox, a company fighting to end this unseen environmental crisis by transforming how the construction industry manages its liquid waste.
Innovation, resiliency, discovery. Join Mike Lake, President and CEO of Leading Cities, as we explore the technologies shaping the possibilities of our future with a preview of tomorrow.
Hello and welcome, Andrew. Thank you so much for joining us today, and welcome to all of our listeners. Today, I'm excited to introduce you to Andrew Crimston, the founder of Geosentinel Australia, also known as Washbox. His organization is tackling a significant environmental challenge: the discharge of liquid waste from construction sites, which impacts both environment and site outcomes. Probably something most of us have not thought anything about. Andrew, let's start by learning a little bit more about your background and what inspired you to tackle this challenge and address environmental challenges associated with construction projects.
Thanks, Mike. It's great to be with you today. My background is in construction trades, and so when you're in and around construction sites, you see a whole lot of activities that go on. And so a number of years ago, I became aware, almost at the same time, of this impact of construction site discharge from trades washing tools. I've got a commercial painting background, and so that's what we do. And at the same time, I became aware of the ocean impact of sewer discharges. And so kind of when you put two and two together, and you see people washing tools using drinking water, discharging it to the sewer, and then you hear stories of ocean impact from sewer discharge, you kind of think, hey, what are we doing here?
Absolutely. It's amazing. For working with cities, this idea of sewer discharge is such a huge issue. And it does have incredible impacts. As we know, we've talked about on this podcast and all throughout the news. I mean, the massive amounts of plastics that end up in our oceans, with the often cited stat that we'll soon have more plastic than fish in the oceans. But the chemicals is something that we don't talk as much about. And in this case, it's not just the chemicals, but microplastics as well. Isn't that correct?
Yeah, it is. And when you think about the way technological advancements have kind of led the way in a whole range of construction materials. So if you think about coatings, for instance, that might be designed to protect the outside of a building, these types of coatings dry as plastic films, and they're designed to last in the environment for sometimes 20 and 30 years to protect the outside of a building. But if that plastic film dries or begins to dry on tools of application like rollers and paintbrushes as examples, and then when they're washed, they wash off as microplastics, you've got these microplastics being discharged to the environment, which are designed to last for a very, very long time.
And this is a stat that really bothers me. And for anybody who is listening to this and hungry at the moment, you might want to think twice about grabbing a snack, because on average, we all consume a credit card worth of plastic or microplastics each week. It's an unbelievable statistic to me. I mean, it's like beyond my comprehension that's the quantity of plastic that we're consuming. But when you talk about all the many ways that we're contributing microplastics to the environment, ultimately to our own water and food sources, it's actually not that surprising.
Yeah, well, when you look at some of the data that we collect as a business through our site operations, we test our waste material that's captured by our solution for microplastics. And so we know that there's 174,000 microplastics in every litre of construction waste products that's washed from tools. It's a pretty staggering number.
And do you have a sense of how many liters, for instance, a construction liters of that contaminated water a construction site actually, creates or has?
Yeah, so we record data across a whole range of different types and sizes of construction. So whether it's a school or a hospital, a multi-story residential multifamily building, or a commercial high-rise, we can share data that will allow construction companies to forecast how much water they're going to use in the first place, how much fresh water used, drinking water for washing tools, and then how much liquid waste pollution they're going to generate, including what the volume of solids is, which is typically around 10 litres for every square metre of construction. That's typically the volume of pollution generated. And 7 to 10% of that is generally solid waste. So, if you look at, global forecasts of construction activity and look at how the world is regenerating building stock for green building and for efficiency, there is a very, very large impact from this particular activity.
Mm-hmm. We've, on a previous edition of Preview of Tomorrow, we had another Acela City alum who filters microplastics. So looking at it, one of the things I recall looking at it through the lens of a city is that most wastewater treatment plants are unable to fully filter out microplastics. So it's not, even the fact that if it is entering the sewer system and not being discharged, but actually going through the water treatment and then being discharged, those microplastics are still there.
Yeah, that's correct. They are. And wastewater treatment plants are, they're not magic places, Mike, where waste disappears. And I think there's a little bit of a feeling in the community that when we flush the toilet or we wash something down the sink, that there's this, there's this kind of, this process that we call treatment that somehow does something to that waste, which makes it okay. But the fact of the matter is that 80% of the world's wastewaters go directly back to the ocean without any treatment whatsoever. Out of the 20% that is treated, 80% of that only has primary treatment, which is like screening it through a piece of mesh. And that's what they call wastewater treatment. So anything that's not large enough to be captured gets discharged to the ocean, including microplastics. Anything that is captured goes into this this kind of product, I guess, called biomass, which goes to farms as fertilizer, or if it's far too contaminated, goes to landfill. But that's another pathway for this contamination to get back to the environment, or even worse, into our food chain if it's used as fertilizer on farming crops or grazing animals.
Which actually, you just reminded me of another solution that's come through Preview of Tomorrow, is dealing with that sludge, that hazardous sludge that's left over at a wastewater treatment plant, and it neutralizes it so it's no longer hazardous. But what I remember from that episode is that something like 80% of the cost of wastewater treatment facilities is actually dealing with that sludge because it is hazardous material and therefore very expensive to contain, transport, dump, etc. So if you can prevent it from becoming that hazardous, at the source, all the better. So let's dive in. And by the way, on the backdrop of the fact that I don't know if anybody listening to this was thirsty as we started, but thinking about what we've just talked about, you might want to think twice before grabbing that glass of water. But the reality is only about 1% of the Earth's water is actually drinkable, right? Potable water. And to think that we are contaminating this I mean, critical resource for human survival is another whole discussion for another day. But I do want to focus on Washbox, and I mean, we clearly have set the bar in terms of this is a real issue. It affects everybody. I mean, there is nobody that is unaffected by this because we're all connected through our oceans and the water supplies and everything else. So, what is it that Washbox does, and how does it do what it does?
So if we look at a very simple example, during the construction and fit out of buildings, there's a whole lot of liquid-based finishes that need to be applied by hand tools. So we're talking paint, plaster, tile, grout and adhesive, patching and filling compounds, sand and cement render, plaster, those types of products. And those applicators need to keep their tools relatively clean during the process so that they can maintain a high quality finish. And that's because these products are designed to dry and go hard, as we discussed earlier. So if you don't keep those tools clean, then the product begins to dry on the tools, and that affects the ability of the applicator to deliver a good finish. So the problem then becomes that we need a solution on every construction and fit out project on the planet that allows those tools to be washed without discharging the wash water to the sewer. So Washbox was developed as a solution that can eliminate the need to use drinking water in the first place. And in doing so, because we're able to recycle continuously a small batch of water, we eliminate the need to discharge any liquid waste. And so Washbox is an automatic solution that's available for hire that allows any trade to wash their tools in recycled water, and the Washbox automatically separates the waste material out so it can be disposed of as a solid.
So, I mean, you are capturing it right there at the source. You're eliminating the problem before it's actually even a problem, at least in construction sites.
Yeah.
I mean, I'm struggling to think of a single reason why this would not be a requirement on every construction site in the world. I'm sure there's a cost associated with it, obviously, but is that even prohibitive?
No, of course not. Washbox is for hire globally for, if we're talking US dollars, around $550 a week. We're deployed on projects that are worth hundreds of millions and sometimes billions of dollars to construct. In 2023, the average cost of deployment on a project was about $15,000, and the average value of those projects was sort of in the range of 200 million plus. So we're talking 15,000.
Let me interrupt 1 second. I mean, a $200 million plus project and only costing 15,000. I mean, this is a rounding error at best. But beyond that, I mean, this is also sounds like it's a big project. I mean, it is a big project with a price tag like that. So this is not just home repairs for a week or two. This is a multi-month, maybe even multi-year project, right?
Yeah, correct. So the average duration that Washbox was used on a project in 2023 was 24 weeks.
Okay, so 6 months.
Yeah.
So, all right, cost is not the issue. Is it then just an awareness issue? Is that the?
Yeah, it really is. Construction uses a particular system, which is the installation of 44-gallon drums connected to the sewer. It's not compliant in most regions globally, and the industry continues to use this method because they've got a kind of a supply chain that's factored into the way they build. So they've got contracts in place, and they're used to engaging a plumbing or hydraulic contractor, and part of their package, their tender package, is to install 44-gallon drums that are connected to the sewer. And then site management is used to managing those 44-gallon drums that are connected to the sewer, even though they're pretty horrendous and problematic. And so in order for us to replace the go-to, which is these 44-gallon drums connected to the sewer, with a technology solution like Washbox, we need to engage with the whole supply chain of the building company. So we need to be talking to them as they're budgeting for the building, as they're putting their cost plans together. We need to make sure that the contracts reflect the way they want to build. which is using a technology solution rather than 44-gallon drums. And then we need to follow that all the way through to engagement and make sure that the site teams understand that there's a budget for a technology solution and there's a methodology for implementing it. So whilst on the surface it sounds really simple, we just get rid of the 44-gallon drums and put in a technology solution, there's actually a fair bit of engagement that's required in order to get the construction company to change that behavior.
So I know we talked about the cost of implementing Washbox, but it seems to me there is a real cost in terms of implementing a 44-gallon drum. My question ultimately is, how do those costs compare? And then ultimately, there's obviously the environmental cost, which might not be borne by the actual construction company or the developer or even the property owner or whatever. But it seems to me that dumping this kind of material, I mean, you talked about things hardening. I mean, they're going through pipes and hardening in pipes. You don't want something stuck in your pipe for 30 years. So, I mean, what kind of issues is it causing for the project, the building itself, that might not be considered as part of the cost of construction?
Yeah, so there's that contingent risk impact. So the 44-gallon drums are discharging these solid waste materials to the plumbing in the building during construction. Sometimes that's temporary plumbing, but sometimes it's the fixed plumbing that's going to exist for the life of the building. And so we see huge impact during construction on programs through the time taken to clear plumbing that's blocked or restricted from this particular waste. And if you can think, if the plumbing does block and then people continue to try and wash this waste into that plumbing, it'll overflow. Sometimes it collapses. Sometimes the building's handed over. If it's a residential apartment building, it's handed over with significant plumbing restrictions. And then when people move in and start putting toilet paper down the plumbing, it blocks. And then the construction company's got to come back and excavate that plumbing out of concrete slabs and move people out of their house for 6 months while it's rectified and then rebuilt. There's massive contingent risk. We've got examples of customers.
Not to mention bills and costs.
Yes, 100%. Really, really significant costs. And some constructors, some project management teams actually budget a cost in their plumbing contracts to snake out the pipes up to 12 times during the project.
Wow.
So we eliminate all of that cost. On a large project, Washbox is significantly cheaper than not using it.
That's amazing. Well, I mean, we've established the need for it. We've established all the reasons why to have it. Let's just for a moment think 50 years from now. Let's look into the future. That now my hope is that Washbox is in every construction site on the planet. What does that actually mean? Like, give me a sense of the impact that would create versus not having Washbox at all.
So to give you an indication, there's a common forecast that's thrown around that we need to reconstruct New York City every month for the next 40 years in order to satisfy our need for urbanization and to regenerate building stock for efficiency, to reduce the embodied carbon and the climate impact of building, which is significant. If we just look at that forecast, based on data that Washbox records from construction activity, we know that the pollution generated just in commercial construction is about 2.3 trillion litres over that period of time. And that contains about 115 billion litres with a B of raw paint, plaster, grout, tile adhesive and other compounds that'll be discharged to the environment. So we've got the potential, if we deal with this now, to draw a line in the sand. And so we're not going to allow 115 billion litres of these complex chemical solutions to be discharged to our environment over the next 40 or 50 years.
Absolutely. I mean, the environmental impacts are actually, I'm just thinking all of the various ways. I mean, from wildlife to, of course, the drinking water we've talked about, et cetera, et cetera, et cetera. Listen, I want to, unfortunately, we're out of time. It goes way too fast. I think you've made the case for why, you certainly made it for me, as to why the Washbox should be on every construction site. It's a no-brainer. And it certainly helps, I would think, any developer or construction company to increase its green efforts, its sustainability efforts. But I just want to thank you for taking the time, not just to join us here on Preview of Tomorrow, but to take this career shift, and really have such an impact in a place where so many of us, myself included, would otherwise be ignorant to and take for granted.
Thanks, Mike. It's a real pleasure, and it's a journey we're on, but we're making some serious inroads and looking forward to, the opportunity to really help the construction industry build better ultimately.
And thank you for tuning in to this episode of Preview of Tomorrow. Listeners like you are essential to advancing our efforts to drive resiliency and sustainability for all. I ask that you give us a rating on Apple Podcasts or whichever streaming platform you prefer. Your feedback helps us to grow and share these brief previews of what life in the future can be. If you enjoyed this episode, please subscribe and encourage others to also join us each week in previewing the possibilities of tomorrow.
Preview of Tomorrow is brought to you by Leading Cities, a global nonprofit driving resilience and sustainability for all by unleashing the potential of the world's cities. Join them at leadingcities.org.